So in this module, we'll go over several synthesis techniques. Synthesis covers both type synthesis as well as size or geometry synthesis. And we'll walk through some techniques for us to understand how to basically create a mechanism and specify the lengths of the lengths. So in this case, we've already determined the type of the mechanism. And the type of the mechanism here is an inline slider crank. And the steps associated with this, I will show you drawing through this. So you see here at the bottom what we have is the slider portion of the slider crank, and it's in two extreme positions. It's in the extreme left position and the extreme right position, or what we can call these top dead center and bottom dead center. So I'm going to locate a point within this slider. Okay, that point is going to be in the same location in both positions, and we'll call this C1 and this C2. So this is joint C in the first position and joint C in the second position. And what we've done is located the axis of the pin on the slider and then drawn that in the two extreme positions. What we want to do now is draw a construction line along the displacement. So here's the construction line here. So what we do is we connect C2 to C1 and draw a construction line to the left and to the right. Now we can find the distance from C1 to C2, okay? And we can do this by bisecting this throw distance. So here is the distance from C1 to C2. And we can bisect it. We can bisect this by taking a measurement from C1 to C2, or we can do a perpendicular bisector. So in this case, we'll take the bisector to be approximately here. And when we bisect this throw distance is the length of the crank, or L2. Okay? So this distance here to here is the crank length. Or L2. Okay? So once we get the bisector, I can now pick a point along this line, along this construction line, and I'll pick it out over here. I'll make that a ground joint. Now, whatever the length of this is, okay, this length of this crank, I'm going to draw a circle around that line. Okay, and you would draw this with a compass. Draw a circle around this joint A. Okay. Okay, and that is going to be the length, right? So here's the length. So now what we have here is there's joint A. This we'll call B2. Okay, this is pointing all the way to the left. Okay, and now what we'll do is we will draw the coupler. So the coupler comes in. And it couples. So we've got L2, L3, and this slider in the two positions. So now we've drawn the coupler. So what I can do now is I've got L2 and I know the length of it. I've got L3, I can get the length of it, and determine from knowing these, I can run through calculation on motion. I can do it on velocity. And I can do it on acceleration. And I can get out things like, say, pressure angle or mechanical advantage. So here I can tell the goodness of our design, or our device. So what we've done here is now an inline slider crank.